let's get started. I think we'll spend the rest of the day, we have just over an hour, to learn how to process this table and to look into our results. And if we do that in a good way, then what we can do tomorrow in the morning is we can start the non-targeted by the automatic analytics way, and then tomorrow afternoon we can continue in the manual. I think that'll be good, and we pretty much cover all the basic processing by the end of the week. Oh, well, I should say the end of my week. You guys continue on Friday, right? Okay, so this is the chart. You'll spend a lot of time looking at this chart. And the first thing to note about the chart is you have a couple different ways to sort the chart. On the left side, you have a tab where you can look by sample. And you have a tab where you can look by component. In each case, you can go to individual samples here, say all components, or you can say the individual components. So you see when I'm clicking there, the table is simplifying and showing only what I'm clicking. So all components means all components, all samples. Samples means the individual samples, but still components, and so on. So you can use these two left tabs to jump quickly to what you'd like to see. Each column is also filterable and sortable. So if you want to sort the table by a certain column, you highlight the column, and then you have here two buttons to sort, smallest to largest, or largest to smallest. So smallest to largest is the same thing as A to Z, and biggest, largest to smallest is Z to A, in case of alphabetical, or for numbers, of course, that's easy. If you want to remove any sorting, you can click this button, removes any previous sorting, and it goes back to the index, which is basically the sample order that you put them when you move them over to the right side when you first built the chart. Each column also has a filter, so this little funnel is a filter, and for example, if you click that funnel, then you have the choices. You can say you want to see all, or you want to see nothing, and you want to see, okay, only those two compounds. It will show you only those two. And then once a filter is applied, you see that it's in blue. See the dark blue? So then I can say, okay, clear the filter. And now it goes back. You can also move the columns around. So if I highlight a column like this, and then I click and drag from the top, I get two black arrows, and the column can be moved to that position. So really, the software is, in this point, I think really excellent, that you can create a layout that helps you see the data that you want to see. You can also control which columns are visible. For example, we are not using groups right now, and we are not using the accuracy or the concentration. So to do that part, I can come to more, and I can say table display settings. And here I have all the possible columns. So these are all the pieces of data that are saved when you collect the data. So you have many variables here. And I do encourage you to come and look at this, by yourself and see what you can display and so on. So I'm just going to remove now the columns that I don't think are necessary for qualitative screening. So we don't need actual concentration. We don't need accuracy acceptance. We don't need accuracy. Attic and charge is nice to have. Area is important still. Let's see, we don't need calculated concentration. I'll show the combined score. So that's the score that we set up from the four parameters that we're looking at. We don't need the group name. We don't need component type. Concentration acceptance, we are not doing in this. Expected retention time is good. Formula we can show. Let's see, found at mass is good. You can add in height if you want. Fragment mass we don't need. Index is fine, so you can display things like injection volume if you want. A lot of this stuff we'll talk about, but it's just a little bit too much for the first day. Isotope confidence and isotope ratio difference we want. Library we definitely want. Mass error we definitely want. You can click the mass info if you want. That'll actually display the mass. The MS method if you want. Operator name, file name. You can add in a comment. Precursor is good. Let's see what else. Rack we don't need. Reportable is good. Retention time difference, delta, retention confidence, sample name, sample type. Okay, we don't really need sample type, but we'll keep it, and then used. Okay, so I'm going to say okay. So you see I got rid of all the columns I don't need. Now I have everything on one page. Now personally, this is just my personal preference. I like to have all my traffic lights over here on the very left. Maybe it's the internet. Okay, well, I don't want to waste too much time if I can't do it. But as you can see, you can move all of your columns over. So the point of doing this is I'll then show you how to save this layout. Sample name. Doesn't want to let me move sample name, does it? All right. So now you have your preferred layout. As you saw, that took some time to set up, and you might think, okay, this guy's wasting time. But what you can do now is you can save this layout. So we can go back to table display settings, and now here you have import and export. So you can go to export, and you can save this layout. So I keep always my layout settings in my SCIEX OS data folder, and I give it the layout name what I'm looking at. So this is targeted screen with library search. I'll put my name too, so it's, you guys know it's my one. All right, so then save. So now the next time that you open a result table or you create a result table, you don't have to do all of that work. You can come directly to more, and you can say here under recent table settings, and it has it memorized. So you'll just be able to click there once, and poof, you will get exactly your layout. All right, so that's the layout of the table. Let's talk a little bit more on how to look at the data. So you have this button here, and this button allows you to see what's called the peak review. So if you click on that button, what opens below are the three panes, and you recognize these three panes from the lectures, right? Because we saw all of those, all of the data from the instrument. Here's the XIC, it's always on the left. Here is the mass spectrum, always in the center. And here is the MSMS spectrum on the right side. So that's always how they're oriented. And whichever one you click in the table, it will show you that data from that line. So you can quickly, now you know how to sort your table, you can quickly do that and find which ones you want to look at, and then you can go through them one by one and actually look at the data down below. So first of all, we have a lot of red marks, which for libraries, so we need to investigate why we have that. But the good thing is the mass error and the retention times are all good. I prefer a little bit more zoom here for the XIC, so I'll show you how to set that view up. First of all, under view, you have the different 3 different kinds of data you can see. I think probably you will always keep it on that one, but if for some reason you wanted to zoom in or something and not see the MS, you can choose that, for example, without the MS. And then under options, you have the peak review display settings. And here you are speaking about the settings of how this data is shown to you. Under zooming, I will say zoom for 3 retention time windows. So that'll be about 1.5 minutes, right? Because the retention time window is 30 seconds. So we'll just say yes to that. No, that's half, so it's 3 minutes. Okay, I will change it a little bit. And we'll put 2 half. All right. So I want to actually see the peak. Okay, that's good. And then we have the mass, and here we have the MSMS. Okay, so any questions on how we got to this point? Now I have the data in a very nice way to look at it, and I'm now prepared to go through the data rapidly and to see what I can actually find in the data. Any questions?
I think this is good for now.
Good for now. All right, great. Okay, so let's continue and let's look now about what we are being told in this data. So yeah, let's choose this one. Okay, no problem. This is atrazine. So what do you see for atrazine? Okay, you see a nice peak in the XIC, and you have this red line. So the red line is where the MS and the MSMS is taken from. So this mass spectrum is the mass spectrum, not of the whole peak, but it is the mass spectrum at that red line. And the same thing, this is the MSMS spectrum that was taken from this peak, also only at the red line. And you see some overlay here. So the overlay, now the overlay is pretty good. Let's zoom in. You see the gray? So the gray is the overlay, and that is the isotope ratio of this compound. So this compound is, here's the formula, C8H14ClN5. So you see there's the monoisotopic, there's the 1C13, and this one is a little taller. This is the 2C13, but it's also the chlorine 35, the chlorine 37. Right? This is 1 chlorine 37, which is 2 Daltons heavier than the 216. You can see that lined up, and there is also a percentage, isotope ratio percentage right here. So we are within 15% of what the isotope ratio should be. Now you may think, okay, 15% is not very good. Well, look at also what's happening in this data. You have also other masses here, and these other masses are contributing, especially here. See that the ratio should be that high, but it's actually a little bit higher. So that is why we have that 15%. This is pretty low intensity, and that can be considered perhaps the C13 isotope of whatever this mass is here, 214.9175. So in this case, I kind of accept that that's okay, because there are these other masses close by which are interfering with the isotope pattern. And you see we set the percentage to be yellow at 15. So that's why we have 1 yellow mark there, because this is like borderline acceptance. And so don't forget, I set that up. I didn't know that 15 was going to be like that, but that's a good case of where you would perhaps like to adjust that for your own flexibility if you want to flag something like this or if you want to accept something like this. Now we have the MSMS, and you can see that library confidence is all red. And we have here the library match in this column, library hit, and it says no match. So I'm just wondering why that is. They're all red, because that is a little bit unusual. Okay, let's go and check. So the libraries are controlled by a license. Let's just take a break here and go and see if the library licenses are okay. So you have a software called Library View. Yep, here it is right here. So we'll just check in the Library View. That is the condition of the library. Excuse me. Library View is a bit slow. It's a second to open. It didn't open on the other window, did it? Maybe I didn't click. Yeah, okay. All right. So this is your library view, and here you can actually see all of your libraries, and you can go to the library and you can view the compounds, and you can see the spectra in the compounds. So this, you can't do any searching or anything from this library view software. You have to do the searching in the OS, but you can at least see the compounds. Aldecarb, and that's why you don't have a license. So maybe they never installed the license for you. Samar, are you there? Can you give me some advice what if they installed the license or not?
Hi, Alex.
Hello.
Okay, we installed the license. It was installed, but I don't know how come now it's not working.
Okay, well the
It
service.
was working.
Yeah, okay, it was working. You're sure it
Yeah.
was working? Okay. So then probably.
At least in the library view, we could see it.
Yeah, okay. So probably the service just stopped. Maybe if the computer hasn't been restarted in a while. Let's just take a look here. You have the all-in-one. Okay. So I will just open this. So it was issued on 8th of October, and it's permanent. So it should, oh no, it was 26th of November. Start. But it was issued on 8th. Okay, should be okay. So what I'll do is we may have to restart the computer, but I'll show you a trick if that happens. So just go ahead and close the library view. And what you can do is you can come to services, which is right here. And you can find the service which controls the library, and that is called Library View Service. Library View Service Host. And what we can do is we can just say here, restart. Okay, so just do that little trick. And then let's look in Library View again. Come on, library view. There it is. All right, so let's go back, pesticide, and Aldi card, and there we go. See that? So now it's not in red, and it's in blue, and we can see the library match. Or sorry, we can see the library information, the library hit, the data of the library. So if that does happen to you, you can just try that little trick, or you can restart the computer. Sometimes it does lose its license, unfortunately. So that is why we have red for every library match, which is just doesn't make sense, right? We should at least get something. So what we can do is we can, there's two ways you can do it. You can process again data, or you can reselect the peak in the XIC. So every time you click and drag across the peak, it reselects it, and then it will also do the library search. And now you see we have a green check for the library, and it matches the atrazine. So the library is displayed to you upside down. So it's called like the mirror image. So every peak that has every peak in the data you see has a match in the library in order to give a good score. Now I cannot see. Yeah, okay. So here are the scores, and you see this is very typical of IDA data because it's very clean MSMS. You have a high score for each of the scores, not only just purity, but fit and reverse fit. So when we do the swath data, you'll see that the reverse fit and the purity won't be as good, but the fit will be good. So there's the library match, so we can confirm that the atrazine is present in the sample. So we can just go through the others. You see, unfortunately, because the license was missing, so I'll just click and drag across, and as soon as I do that, I get the library match. And this concentration was, what, 10 nanograms per mil? And our method has wider peaks, I hope, and also has more data points. So we should even get, from our data, we should get better quality than this. What is this? Prometrian. Yes, Prometrian. Propazine. Simazine. And the last one is Terbutrin. All right, good. What happened here? Yes, okay. So this is a more realistic result. Actually, what I'm going to do, because of that library license problem, is I'm just going to reprocess, because I want to show you something in the data, and I want to see if you can work it out. There is one problem with the triazines, and I'll see, so we have a red mark there, even though we have a good library match. But the problem is we have red marks everywhere, so it's not obvious. So what I will do is I will just close this one, and I will reprocess the same data with all the same methods and the same layout. And then I'm going to ask you guys why Prometrian has a red mark. So we'll just investigate that together. So we'll go to results and listen new, and I'll grab the same data. So I believe it was these three, or at least three similar to that. Browse, and here is our method, which we made it just now. And we'll say open, and then we'll say process. So that also gives you an idea of how quick the processing is when you have your method already ready to go. Don't need to look at your method. Okay, so now we have the layout, and the layout is all wrong, or not wrong, but not how we want it. So we can come here to recent table settings, and we can say my settings. Now it's all nice, and then here we have the peak review. And so what we notice is, okay, we already talked about why, we might have, for example, a yellow mark there based on the isotope ratio not being so correct because of an interfering mass affecting the ratio. But here we have a red mark, and see it in each case for prometrine, right? There's a red circle. So I'll leave it on prometrine. There's the prometrine. Can anybody look at that and try to explain to us why we have a red mark for prometrium?
I think there is a mass in the data that's not showing in the library.
There is a mass in the data which is not showing in the library. Okay.
And the purity is very low.
Right, that's exactly correct. Right here, right? You see that? Here it is. Look, you have 186 in the data, and there is no match in the library. Is that what you were referring to?
Yes, exactly.
Okay, great. So that's correct, but unfortunately that's only half the answer. So now we need to understand why. So what is going on? This is IDA data. IDA should be clean MSMS, right? We are selecting specifically the parent. We are selecting 242, right? We are selecting 242 in the Q1, and we are fragmenting that into Q2, and these are all of the daughters from 242. We have a beautiful clean XIC, right? So it's not like there was, another mass at a different retention time. So where did that 186 come from? How did it get there? If this was, we didn't talk about SWAF in detail, but if this was SWAF data, it would kind of make sense, right? Because maybe the 186 came from another parent. But this is not SWAF data, this is IDA. So the answer is in the chart. Here in the chart. What do you see in the chart about the other compounds? Don't focus now on prometrine, focus on the other compounds. One of the other compounds has something similar to prometrine. What is the similarity? Simazine, okay. What do you see is similar about simazine?
The mass is quite near that of the prometrine.
So prometrine we have 242 and simazine is 202. So they are 40 Daltons apart.
No, I saw something wrong. It's the terbutrine. I don't know.
Okay, terbutrine, yeah. Okay, yeah, terbutrine. So what's wrong with terbutrine? I also don't know how to pronounce it. Don't worry, these names are horrible. Pesticides are the worst. What's wrong with terbutrine? Or what can we say about terbutrine and prometrine? A special word. We used it in a lecture.
Isomers.
Yes, they are isomers of each other. Exactly correct. So they are isomers of each other, and not only are they isomers of each other, but unfortunately they have the same retention time. In this chromatography, they are not separated. So that's why I mentioned the XIC. The XIC is very deceiving because they coalute. So the chromatography is not able to separate them. So unfortunately, the left side picture gives one result, which looks good. By definition, they have the same mass and they have the same isotope pattern because they have the same formula. So by definition, the mass spectrum has to be the same, the center. So we don't learn any clues from that. But now look, this is the terbutrine. Right, this is the terbutrine data. What do you see different here than we saw in the prometrium? Focus on that 186. And also take a look at the purity. Purity is also not great, right? So the 186 is coming from terbutrin. See that it has a match. Which peak doesn't have a match? See the 200, right?
200, yes.
Yeah, 200 has no match. But unfortunately, 200 by percentage of intensity is quite small. So it's not affecting the purity as much as the 186 was in the prometrin. So here we don't see a match. The purity is only affected a little bit, but still it's not a perfect match. And prometrin, I'll just go back to it and I'll show you. Look, the 200 is matching, but the 186 is not. But the 186 is a big intense peak, makes up a lot of intensity, so it affects the purity a lot more. And also you see there are two doubles here, 1, 2, and 2 here, 1, 2, which also don't match. So here we have two compounds. They are exactly the same mass. They're isomers of each other. They coalute, so they come to the ion source at the same time. The Q1 cannot separate them in the MSMS as they are the same mass. So they both pass through the Q1 together, or 2, the parent selection, and then they are fragmented together and their daughter ions are a big jumble all together. So we get one MSMS spectrum, which is a combination of prometrin and terbutrin. So this is a little trick, which I like in the triazine mix because it helps you to understand perhaps some of the limitations of the instrument, but also to look at the data analysis and to take a look and see what you need to look at. So even though terbutrin has 4 green marks, right, that purity score, even though it's still quite good, is not great because you are missing one key diagnostic fragment right there. That is important, even though that is a small detail. For the prometrin, it's easier because we have the red mark because a very big fragment was not matched. But these are the kind of things that you have to look out for in your screening. And I think what we'll do, unfortunately, we discovered this now, so we know it in our minds. But when we do the in silico fragmentation, maybe we'll do that tomorrow. We'll use the same data and we'll look at it and we'll see how that affects the in silico fragmentation, or let's say the building of the structure from the data, because that will affect it. Did you spike the triazines, by the way, into the samples we ran yesterday? Because maybe our chromatography is better than this, and then we have actual separation in the chromatography.
Yes, we did, Alek.
Okay, great. So we can look at that as well.
Everything labeled B, we spoke those.
Okay, we spiked. All right. So, but let's. I'll open it up for questions here. But then what we can do next, in the next half hour or so, or 40 minutes, whatever we have, we'll process the spiked samples from yesterday, and we'll look and we'll see if we separated prometrin and terbutrin. That'll be the next step, what we'll do. But does anyone have any questions on this or anything else in the chart that they look at that they think is interesting or they want to know about? Everyone okay? All right. So I'm going to save this chart. So we have the data saved, the results chart, so save as. Now I use the same date what I did for the data file. So this data was collected yesterday. So I'm going to use yesterday's date, which was the 8th of December. And then I will say triazines IDA, and I will put it with the install chromatography, right? Because that tells us Chromatography, yeah, it's spelled right. Okay. All right, so that chart is saved. So when you open a chart, just keep in mind you only save the chart. So let's say if I open that again just to show you, right? Here we come, chart, open. So, come on. So you open the chart like that, right? So if you want to go to peak review, you have to click there again and see the peak review. So every time it's just the chart what opens. Alrighty, so let's see here now. We'll go to new results, right? And we'll find the data that we ran yesterday. So where is that? We're in the wrong project, right? So this is not the right project. That's good that I did that. We can change also the project from here. So Triad Training is the right project. Now we'll go to results and we'll go to new. Right, here's our data. Okay, so here's a question for you. Can we use the processing method we just made, can we use it for this data we ran last night?
I believe we can. I think so.
If we're looking for triazines, yes.
Right, okay, but what's different? There's one thing that's different. And you think what's the one thing that's different?
It depends what to choose from purity or fit on the.
Okay,
processing,
right. So if we let's say we'll look at the IDA data.
It should be the same.
IDA.
Not IDA.
It should be the same. If we're looking at
Okay.
IDA.
Okay, great. So what can anybody think of one other difference? I'll give you a hint. Is the chromatography the same?
Do you mean integration?
Integration will be, yes, perhaps a little bit different, but there is one big difference that will change if the chromatography is not the same. Anybody think what that is? So,
Is it the retention time?
right, exactly correct. So the retention time will not be the same because the chromatography is perhaps very different. I don't know what column Mare used for that data, but I guess he used the little short column.
Correct. Yes.
Yeah, so if retention time is different, then your peak will shift out of the search window. Don't forget, we
Exactly.
set up that search window, right? And then you will find nothing, even though it's there. So be very careful. Even though you are not doing quantitation, you are still finding the compounds in that method, number one, by retention time. If the peak is not in your retention time search window, you will not find it, and it will give you a negative result, even though it's there. So do be careful about that. If you change your chromatography, you need to be thinking, my retention time's changed. I may need to change my method. Does that make sense to everyone?
Yes, makes sense.
All right, great. Okay. So now we did this very quickly, so I didn't add my names. So I need to find the IDA. All right, so you said everything with a B is a spike, is that correct?
Yes.
Yes.
All right, so what we'll do, well, let's just add them all, and then we shouldn't find in the A, right? Do it like that. So you can see I need to, so that's a swath, so we won't do the swath yet, and we'll go up to this one. So 13 to 20. Okay. So I'll just go through the process of making the new method. It'll go reinforce the steps for you, and I'll chat to you about what I'm doing as I do it, but I'll just go a little bit faster because we already just So we're going to set up the same kind of screening method. So I'll leave both of those checked. And I need to decide my reference sample. I need to choose my reference sample. So I am going to choose something that is spiked. So that'll be the B sample, right? The B has the triazines in it. If I choose the A as the reference, I won't see any. So I have to choose the B as the reference sample. And then I'll go to components, and I'll grab that same data from my Excel sheet, triazines. Here we go. So this was the formula. And I'll put the formulas here. And I'll just grab the names. Start here. Here. All right, so that's basically the chart filled out. I think we didn't do anything else in the chart. So we'll move to integration. Great, so we see a nice peak, and probably we have a peak width, yeah, a little bit wider. We do have a few more data points. The peak is a little bit narrow. All right, so that is 0.1. So the peaks are wider, so they're about 0.2. So that is good. Get more data points. Oh, yes, I want to apply. Okay, so atrazine will do the same thing, 0.2, apply. Chromaton, 0.2, apply. Chromatrine, aha. So, look at that, we did it. So that is the separation of the isomers, right? Chromatrine is one of the compounds that is the isomer. So we see two peaks. They're not perfectly separated, so this is also a good chance for us to use the peak splitting setting. So this is really excellent, actually. So who can tell me which peak is chromatrine? Is it the first peak or the second peak? Or you don't know, you don't have enough information? So we don't have enough information, right? We don't know. We have no way to know which one comes first and which one comes second. The only way to know that is by what? By the MSMS information. As you saw from the MSMS vector, we had that difference of the 186 versus the 200.
الحمد
I
لله
can't remember
ماشي الحال كيف حالك انت؟
now, but 186 was the daughter only in one of the compounds, and 200 was the daughter only in the other. So we could use the MSMS information.
وين ما رجعنا شفناكم وسمعنا صوتكم اختفيتوا.
And actually we know that. We saw examples of it in the lecture, right?
أيوة.
We talked about that. Isomers are by definition the same mass and the same formula, but just put together differently.
وين
Hopefully there will
على
be some difference only
حد
in the
تعرفوه ولا
MSMS.
عندكم؟
So right now we don't know which way it is. One is one and one is the other. We don't know until we get to the MSMS.
أيوة استأجرتوا يعني.
So let's set up the peak splitting and so on, and we'll just guess. We'll say
في ثلاج دخلها؟
second, and then I'll show you how to check
Okay.
that when we get to the data.
حلو.
All right, so I'm going to adjust the peak splitting window, and I'm going to put 0.1,
نايس.
and then the peak splitting, I
والله
will
الحمد لله أنا تمام.
say 1 here, apply.
الساعة
Right,
بدأ.
so now you see I'm able to split them.
إيه والله كنت تعبان جيت على البيت هالكان.
So I have the retention time, and I made the baseline subtraction window with the peak, and then I decrease the peak splitting factor in order to split. And I'll do the same thing for terbutrin, but I'll focus on getting this.
شو ما تعودوا تشتغلوا عنا أنتم مرتاح ولا بطلتوها؟
I don't know it's correct.
كنا ناطرينكم هيديك النهار.
No way to know. Just a guess, and we'll go and check in the data together, and we'll decide which one is right.
معكم هالأسبوع إذا بدكم تلحقوا.
Easy. Here we are. 0.1.
بعدين بنرجع كل شيء استأجرناه لأصحابينه. ستاندات قطريات وبلوطات.
And then terbutrin should be the double. Right, here's the double. Right, so we're going to try to force force it to that side. So set
So-
baseline subtraction
so-
0.1.
انت شوف ساعة
I'll
بدك
reduce the peak
مجازين.
splitting a little bit, and then I'm going to click and drag on that side.
سهل.
So you can also type if you want. If you want to type the expected
اليوم إذا بدك
now I
عشية
forced it half
ما عندي
that.
شيء أنا.
So
فينا
I
نروح
can
نشوف
try this
شو
one
بطلع.
as chrometry first, and the second one is distribution. Again, I don't know it's correct. I just made it.
أيوة
random guess.
تحتفلوا مع
I
أهلتك.
50% chance I'm wrong, right? Okay, so that's
Yeah,
done with the
that's-
integration.
okay.
Any questions on that? Everybody understand what we did?
أيوة شو عم تدرس لها؟
Yes, clear.
حلو.
So library search, I'll set up the same
وين عم
parameters.
تعملها؟
I'll turn off the collision energy and
لا بس
leave
إنه
it as purity.
جامعة ولا
I
كيف؟
put 0.05 here, and I put 0.5 here.
حلو.
Calculated columns. we won't
وبعيد
do
ما
that
هيك؟
right
مش
now.
بلا مش
Line
بلا.
rules. Turn these off. I turn
كم بدك تدفع
on
من جاي
quality
من جاي
rules.
بتغيرك؟
And
جاي
I
بدك تدفع. ضحكتني.
select the same things. Now I have to
Right.
remember my settings, right? I put 3 and 7. And retention time I put
سريع حسب
0.2, I think, 0.4,
حسب
and I changed it to absolute. And I put
الحمد لله. الحمد لله.
30,
يلا منيح هذا بدي لك
and moderating square left it alone.
إن شاء الله. يلا تخلص صح.
And accept.
غير هيك.
And then
حلوة هيدي لمزعفرة.
so now I'm going to save as.
حلوة.
And
قد إيه كانت
you see
الليلة
that's
يعني؟
why I put in the name of the it's
الليلة
not
ب500
the
آلاف.
project, but if you remember I
عم
put
تنزع.
install chromatography in the name of the method because that
أيوة.
affects the retention time. So what is this?
وكم ليلة عدته؟
Scenes, right? Target
أيوة.
screen.
وقلت لي صار لك فترة بجزين. فكرتك شي 4 أيام أسبوع هذا.
C18 or C18, right? Oops.
إيه وكنت قبل بالجبل عندكم ببواري.
C18. That's
أوكي.
good. Oh, and then library search and IDA.
بس أصغر إذا جبت أوضة أصغر بترخص ما أنتوا لأنكم أخذتوها لتساعوا كلكم. والله فلسفية أحلى.
Disappears. Here it is. All right.
لا
So here's
بنام
our
وبيك.
data. And what do we want to see? We want to have
Sure,
our nice
that's
columns that we all spent that time laying out so we can recent settings. My
إيه والله
settings.
كل يوم.
It jumps to there. And then we click on
بلا بحط لك
review.
اسمك أنا اللي أنت بدك تجي بحط لك اسمك فوتو.
So we can see anything. So
لا
how can we
الأيام
go
تلاميذ ما عم بفوتوا.
quickly to the
بفوتوا.
samples that have spike? Right? To do that, we
لا
can go to the
عادي
samples
خبرني
tab.
فوتك.
We can go directly to
مخبرهم
the B.
فوتو.
So we need B samples.
Sure.
We don't see. So what sample?
الجمعة يمكن الصبح عندي كم شغلة بتخلصها بعد الظهر برجع على اللعبة. قوم بالله. إن شاء الله أهلا وسهلا. شوف ظبطها مع مرتك.
Why are the peaks so
يلتقوا
different
الأولاد
from
ناخذ
the
صورة
digital
الأولاد أربعتهم مع بعض. لا حلو.
time? And look, that's even
إنه صغار
more
وقت
separated.
يكبر. لا حلو. والوقت أكبر يمكن صعب من القطع بس إنه صغار فيش القصة.
Something interesting going on. Why am I seeing my peaks at such a different retention time? Who knows which sample I set up?
إن شاء الله خير.
This is correct.
ماشي.
But that's all of me
يلا
because
نشوفك
that's
عشان
what I use as the reference.
أوكي.
This is also okay. I wonder if maybe we didn't calibrate the column enough. Or maybe you, maybe the person who's the owner of these samples can explain what is the difference between, because this looks like one set of samples, right? TVJ is one set, and then ZK3 is one set. Can someone explain the difference between those? Or is it like two sets of samples?
Basil is responding in the chat. He says yes, true. Two different sets of
Yes.
samples.
Okay, can we get a little bit more information about what might be different, two different sets? Okay, so are they prepared in the same solvent, for example?
Basil or Ghada, can you speak on your mics?
That is a drastic difference because here we are 9 minutes, 9.7, and here we are, and it's correct, I'm sure it'll go green. See that? It goes green. So we have a 5-minute difference. Ooh. Same solvents. Well, we ran with all the same methods, right? Ran with the same chromatography. And let's check retention times here and here are exactly spot on. You see that? But here is 5 minutes earlier. So there has to be some huge difference. Now, it could just be by coincidence that the column was somehow not fully equilibrated or ready for the first 3 samples, or sorry, first 4 samples, and then it got. But we did the TOF MS before this, so this was well into the batch, right? So this is well into the batch. Does everyone follow my logic? You have to be a little bit like a detective here, right? So look, these are the samples that we are talking about here. They are the TOF IDA ones, and we ran them already after a couple hours of running. So probably by then the column is okay. So there has to be, you have to think carefully, there has to be some drastic difference in a trace amount of solvent or something in the samples which causes that retention time shift. Because the methods are the same, right? Where is the LC method? Yeah, look, we chose the same LC method, right, all the way along. Can someone in the lab look and take a look at the wash solvent bottle on the auto sampler? You know, the bottle that is the wash solvent that has the four lines into it. Is there still solvent in that bottle?
Yes, Alek, there is still solvent.
Still solvent in the bottle. Okay, so it's not like we ran out of wash solvent or something. It could be that previously you were washing with a stronger solvent and it somehow got into the flow path and it didn't equilibrate itself out. Let's look at the retention time from this sample, which is early, very early, and we'll see. Okay, so this is good. I'll show you how to add samples. So let's go to analytics. So let's say you have this data set and you'd like to add some cells. I can't talk. Sorry, you want to add some samples to it. You can come to more, and you can say here, add samples. And now you are back to this screen, right, where you have to move things over to the right side. So you can just take any samples and add them to this chart, and then they will appear here below these samples. So what I'm going to do is I'm going to take, the B sample from the TOF MS. But the other ones have the bad retention time. So, well, I shouldn't say bad retention time, right? I should say different. Wait, so what happened here? Where are the TBJs? Underneath. Okay, so we'll take one ZK3 and we'll take one TBJ. Now, this is TOF MS only, right? So we won't see MSMS. But that's okay. The TOF MS will give us the same XIC. It's the same chromatography. So retention time will be the same. Chromatography didn't change. So the XIC and the mass should be the same. So we'll say okay. And those will add and process. And then now we have, as you can see, the samples added. So these are the TOF MS only. Let's go back to the peak review button. Okay, so the ZK is the correct retention time. And now it's correct. Ah. Wow. What is happening? I have to look carefully at the chromatography system. Something is a little bit strange here because our retention times are all over the place. TBJ 13 hex B, TBJ 13 hex B. Yeah, so look at that same sample, very different. So that means it's not the samples. It has to be something with the chromatography. So I'm wondering. It's a little difficult. Yes.
Can we check the pressure if it changed during the run, or maybe if the column wasn't equilibrated long enough?
Yeah, I'm also leaning towards your second point myself, that we don't have enough equilibration time in the column. And so then the column was not prepared to accept the next sample. I think that's pressure. We cannot check, unfortunately, in the run. But what we are seeing is like roughly equal peak shape, even if it's early or even if it's late, right? The peak shape is not changing too much in terms of the width. So I think the pressure is okay. It's not mixed up A and B, is it? Make sure that you have pump A and that it has the water on it, and pump B has the organic. And the valve, that solvent selection valve is correct, right? It has the LED. Channel A is on the left and channel B is on the right of the two LEDs.
Yes, definitely, it is correct.
Correct.
It's on the right.
Okay. A little bit strange. Let's do the same thing with the swath data. I'll just add 2 samples from the swath. Add samples. But we did a very nice column volume calculation, right? So we shouldn't have equilibration problems. Yeah, I want to add that one. And let's find an XK, whatever ZK. There we go. Add that one too. Okay, process that. So these were run towards the end of the batch. So that means in time also, I don't see any green. Back to early. Correct. Now this is early too. ZK 2F2 E. This one? No. It's got to be equilibration time.
Is it early, late, and early?
It's all over the place. Yeah, I'm trying to.
Alek, I think we found the problem.
The mobile
Okay.
freeze is not enough?
I think the line A1 was a bit left above the level. I mean, it was definitely below the level of the water dropped down.
Uh-huh.
It was below the filter.
Ah, okay. So trying to jump out of the bottle. Yeah, that's a problem.
Yes, yes.
Okay, that can make sense. That can make sense. Yeah, because we are trying here to draw some trend, to see some trend that is repeatable, and we don't see anything.
Yes. Probably the water dropped.
Okay. All right. So, unfortunately, I do have to go in 12 minutes because I have an evening meeting today. However, what I could suggest you do, and I don't know, maybe I can ask Samar because I believe she's there with you. Is it correct? Samar, are you in the lab or are you dialing in from your home? So you're at home or somewhere else, not in the lab. I'm at the office. Okay. So, well, I mean, I can leave it open to you guys. What you could do then is you could just purge very well the A and the B now. I would suggest you do 2 rounds of purge in case some air got into the system. And then you could set exactly the same batch running tonight. And then we'll check it together tomorrow. You know, if the retention times are stable. That could be good. Anyway, we have plenty of data here, so if you're not comfortable to do that, it's okay. We can still process this data tomorrow through the different, different ways of processing. But it would be good to have stable retention times for the unknown analysis. That's the key point for the unknown, is that we should have stable retention times. So do you feel comfortable to do that? I think it will take you about 10 or 15 minutes to do the purge, and then you can just change the date and submit the samples again. I can help you now with the batch. Does that sound like a good plan for tonight?
Okay, let us do the purge now.
Okay.
Okay, and then you can resubmit the batch.
Okay. So just remember when you do the purge, of course, you open the purge valve and then you press the purge button and make it go through 2 cycles. So I'll talk about what I'll do in the batch. So in the batch, I will open now the batch that we saved yesterday. Oh, am I in the wrong project? Probably I'm in the wrong project. Yes, I'm in the wrong project, so I'll go to training project. So you see that things are not visible in another project, right? You saw already I made that mistake a couple times today. No, we don't want to save. So there's the batch. All right, so we have the batch here. This is the batch that we had yesterday. So everything in terms of the samples and the method and so on will be fine. All we will do is we'll just copy in the data file with today's date. So we'll collect it into new data files. And I will use we have time, I think. So we can use this, yeah. Let me grab here. I'll grab sample names. I'll copy that to Excel. And then I'll put here. Great. Okay, and we just need to fill this down. And today is, wow, 2017. That's a long time ago. And then I think all of these, we can fill it down. And then here, this will be RDA pause. Now you'll see that our data files will all be great. Oh, except it's not. This is TOF. TOF MS goes to right there. And this is TOF IAA. Goes to there. And this is SWAT. All right, so there's the batch. So that was fairly painless. Once you get good with this template, I think you'll find that you like it a lot better. All right, and then we have all of our unique names with a unique number, and it has after what the sample does. What the sample is, I should say, sorry. So we'll copy that. Then we'll come here, and I'll just paste that here. All the way down, 30 is correct. And then I'll save as 2020 1209A, right? All right, so how's the purge going? If you don't mind, excuse me, you can open the little doors on the pump and you can just see if you see any air bubbles inside the tubing. Keep in mind you have tubing at the back, which is, what is that tubing is basically keeping the back side of the plunger clean. And that tubing may have some air in it. So we are talking about not the very, very soft tubing, but the little bit harder tubing that's clear. You should see all bubbles out of that. See, that's another reason why I don't like those trays, because you can't see the bottom part of the bottle that's in the tray. It's hidden. And then if you're not so tall to see inside, you don't see this kind of problem that we had. Auto calibrate is on every 3 samples. Okay. All right, so the batch is ready to go and save. So basically all you need to do is click submit once you are ready, just in case the purge is not finished by the time I have to go.
Okay, we ran one purge for each, and now we are doing the second purge for each.
All right. And you don't see any air, huh? What happened to the OS? Okay. And how much solvent is left in the bottles? We do need to take that into account.
Okay, we are adjusting a little bit the level of the water. We are adding 500 ml to be on the safe side.
Okay, great. Okay. So we're using 0.5 ml per minute, and we have 30 samples. and each sample is 21.5 minutes. So that is, yeah, you need about 325 mils total solvent for the whole thing. So you should be okay.
We have currently 350, but we're adding them up to
Yeah.
65.
Perfect. Perfect.
Actually, Alek, I wanted to ask you a question.
Mhm.
Can we do some data processing from the Explorer end?
Absolutely, yeah, absolutely, sure. We will definitely do that. We're out of time now today, so we'll definitely do that tomorrow for sure. We need to do that. That's definitely on my agenda. Yes. Well, what we'll do is tomorrow we'll check this data in the excuse me. We'll check this data in the analytics, and we'll just review how to look at it. We will take a quick look at the swath data in the analytics, and then you can make a decision how you want to proceed. Do you want to continue in the analytics with an unknown processing, so to try to find the compounds without giving the formula, or do you want to go to the explore mode? So you guys can make that decision how you want to proceed, and whichever thing we don't do, we'll just do it after. Yeah, I'm sorry. A little bit sore throat from
So
talking.
we'll be doing all of these, but it's a matter of time, right?
Yeah, for sure. We're gonna cover everything.
Mhm.
Don't worry, guys. We're gonna cover everything. Just we have to go at the speed we can go. But don't worry, everything will cover. In fact, that's one of the nice things about the remote is that you're not limited a certain number of days, right? Like maybe I cannot work exactly on the day you want or something because I have so many customers, but it doesn't end. You can continue until you're happy.
Thank you, Alek, for that.
Yeah, no worries.
I think it's better to do some processing on the Explorer end and then move on to the unknown.
Okay, great. The Explorer also has an excellent PDF tutorial. So it really takes you step by step because the Explorer is the same as our very old software called PeakView. So that is really nice. There is a very, really well-written PDF for that. Unfortunately for analytics, there is no PDF. All right, guys, listen, I'm going to have to go. So I've made you the batch. So when the purge is finished, just make sure you close the purge valve. And then all you have to do is go to the SCIEX OS and go to the batch and just click submit. And everything should be fine.
Sure, for sure. We'll do that.
Okay. I have a 1 hour meeting. So I will be available after that. So if there is some huge problem and you want to fix it in 1 hour at 5:30, just write me an email and I'm available after that. But for this hour, I have to go to this meeting.
Sure. If you would like, you can keep connected through Bombar on the PC.
Yes. Okay. Right. But I'll have to leave the Teams because I gotta go to the other person in the Teams.
But keep connected on the Bombar in case we can just chat you there and let you know about our progress.
Fine. So for the rest of you, we won't do any training at that time. So don't feel you're missing out or something. We'll just, if there is a problem, we'll continue. Otherwise, I wish you all a pleasant evening, and we'll continue tomorrow morning at 9:30.
All right, perfect, Alek. Thank you.
Okay,
That's
great,
okay.
guys. Okay, talk to you soon. Have a nice evening. Bye for now.
دايما ليك سؤال بعدين حي عمول هلا نحن حنمثل بلاش اوفر نايت حتى اشوف قديش غريبه هونيك انه كيف لقطها هونيك جوا بالاناليتكس برا ما بتشوف بتلاقي وين انه غريبه عجيبه وين يبيك ما شفناها لقيت سينس في بروسس في طريقه معينه يعني صراحه المفروض كان يوري شيء كويسين لانه كنا صرنا
Collected yesterday, and you can see that the data is actually, okay, you have a DAD, so there are 5 files. So all of those 5 files are what you would need to transfer. I'm not sure if you need to transfer the DAD. To be honest, we didn't use that. I'm not sure that actually you'll get something useful from the DAD and also see it in the mass spectrometer. So for sure you have to take these 3 data files when you go to your third-party software. And if you have the DAD data, then you want to take those 2 as well. So you need all 5 files for each data file. And you can just copy those. You can, I don't know what's your rules about IT and so on. You can put a USB stick into the computer if that's allowed. Of course, just be careful with viruses and all that stuff, or you can do a transfer over the network, whatever you want, and those are the data files. Now, keep in mind they're pretty big, right? So each data file here is about a little bit more than 500 megabytes. So these are big data files. So
actually, it's only allowed via network. Every user here has his own OneDrive account that they can upload it there and have their data wherever they want.
Perfect.
USBs are not allowed in the lab.
USB is not allowed. Great. I like that a lot. So yeah, then you can just upload it to the web, like that person just said, and then you just be aware that they're big files. So it's not something that's going to happen instantaneous. Each data file is about 500 megabytes, and I think when we get down to, so those are the IDA. When we get down to the swath, you can see that the swath is actually a little bit less. The swath files are about 100 megabytes. And probably, actually the first data files were the TOF, right? And then we did the IDA, and then we did the swath. I think that's how we set it up. So anyway, you're looking at about 500 megabytes per file. So just copy from here. That's easy, right? Okay. So what I would like to do before we start is just to go over the batch again, if you don't mind, because we went through that very quickly because I had to leave, yesterday a little bit early. And then we'll also take a look at the queue, and then we'll start looking at the data processing. Okay, so first of all, here's the queue. So we can see that all the samples ran. And the easy way to check that is to just look here that you have this green check mark. And you see that the instrument is now in the ready mode. And if you click on the pumps here, you see that even though it's ready, right, the pump has stopped here. There's no pressure. So the instrument probably ran about 30 minutes after the last sample, continued to pump and so on, and then stop the pumps so you don't have any flow, you don't waste your solvent. For the calibration files, you can double click on the green check mark. And if you double click on the green check mark, you get the calibration report. So you can see these are all the calibrant ions that were used in the calibration mix. And you have here this is the important column to look at, the ppm error after the calibration. So you see here everything is below 1 ppm, even below half a ppm. Oh no, there's one at 0.9. Right, so that's well within the spec of 2 ppm. So to get the report, again, that was to double click on the check mark. So sometimes we may ask you to send us the report from the calibration. If you want to open any data file directly from the queue, you can just double click anywhere else. don't double click on the check mark, but just double click on the line, and the data file opens in what's called Explore mode. Explore mode is the manual data mode. So that's how you can go directly from the queue to looking at your data files. And just double click on the line, and that's the same for the blank here. We can do it as well, right? So there's a blank data file. If the queue gets too busy, you can come up here to manage, and you can say clear the queue. And if you do that, it will just remove everything that's already been run from the queue. Some people like to keep a clean queue, and some people don't really care. So it's up to you. Also, you can use these little arrows here to minimize the queue. And one important point is always remember to scroll down. Sometimes it's a little bit frustrating. You will think, oh, where are my samples? Because it will scroll automatically, and then it will just leave a few rows. So make sure that you always have scrolled down, and the last sample run is here at the bottom of the queue. So the sample that's at the top of the queue is the sample that's run the longest time ago. So you can see when was this during your calibration or during your installation in November. So that's how to navigate around the queue. Let's go back to the batch, and I'll just go over a couple things again in the batch. So you have the batch here. As you can see, we made a unique sample name, and we made a unique data file. Now, our data files are like folders. This is somehow a little bit unusual in our system. Our data files are like folders. There is an advantage to that. That means that the software will never overwrite any data. So if you, for example, have here a data file with the same name, so A030, right? So there, now we have two data files, or sorry, now we have one data file, two samples with the same data file. They will just be added to that data file. So in that sense, our data files are a little bit like folders. It will not overwrite. And we'll see that today when we do the data processing. When you select a data file, you can then select each sample. So what I will do is I will transfer to you an Excel sheet. And the Excel sheet will have a little bit of help for you in running the batch. Just give me a second to find that. SCIEX. And then we have batch creation. Here we go. Okay, so I'm going to say, I'm going to send you a file. Okay. Paste. And then here we go. Open. All right, so I'll put this on the desktop, and I'll put you a copy on the V drive. Copy. So where is V? And then I'll put it in my training folder. All right. Okay, so what this batch file does is, this was my mess from yesterday. Yeah, so let's practice with this. So here's your sample names. So what you can do with this batch file is that it will write sample names for you. So you can type, for example, here, the sample names, and then it will automatically create for you the sample file. And then you can copy both of these columns directly to the SCIEX OS. You can use this as an Excel sheet as well, but you will see once you start working with it that it is a little bit frustrating. It's a little bit slower than Excel. So for those of you who are good in Excel, you may want to use this Excel sheet. And then also you don't have to type so many things. In the Excel sheet, all you have to do is to put in the sample name, and it will automatically create for you the sample file. Now, this is our way of doing it, the SCIEX way of doing it. Of course, you are welcome to do it any way that you want, but we always have the date with the year, the month, and the day. And then we have a letter designation, which you can change, and then accounting. And you see that this sheet takes all of that information and puts it together. Additional information you can omit it if you want. What I find is useful is I put something about the method there. So whether I did TOF MS or IDA or SWAP. And then the sample name, and then it's all put together into this format. And then, like I said, you can just copy this column directly to the batch. You can copy this column directly to the batch. Then all you have to do in the batch is to put in your sample numbers. Your sample positions, right? File positions. And you have to fill out your method and your LC method, which you have to do anyway in the batch. So that Excel sheet saves you a little bit of time and also keeps things organized and allows you always to have sequential data files like in this format based on the date, and then a letter designation, and then a number. So does that make sense for everyone, how to do the batch? Any questions from yesterday? Because I know we went through this very fast. At least the good thing is, that you will never risk overwriting. You may make a mess and put multiple files into the same data file, but you will never lose data by overwriting. So you have that comfort. The data file will be created automatically came in a question. So no. So the data file is not created automatically. For example, if I put, so I'll just type a new sample here to show you. So I'll put here a sample my name. So basically you see that it copies automatically the methods down and all the other information. It automatically increments the vial position, but the data file is left blank. So the sample name and the data file are not linked to each other in our software. That's kind of where the Excel sheet comes in. So if you type the sample names in this batch creation and you use this format, then the data file name will be created for you automatically in Excel, and you can copy it back to OS. But in OS itself, no, unfortunately, the data file is not created automatically. Does that answer your question? Thanks. Okay, sure. So it'll take a little bit of getting used to, I think, but I think in the end you'll get the hang of it. Someone else have a question? Yes. Okay. All right. So the last thing in the batch we can talk about at this point is auto calibration. So it's very important to always have that checked on this instrument to do the auto calibration. If for some reason you don't want to do the calibration, you can just uncheck that little box right there. And then auto calibrate, the button brings up this little window. And basically here you're going to choose what solution you have to do the calibration and which channel. So for right now, I think your two options will be positive or negative mode, which occur here at the bottom of the pull-down menu. And you can set it up any way you want, but when you change to negative, usually people put negative in channel 2. So make sure that you also change the channel that you want to use. What does it mean, channel, right? These are the two channels on the front of the instrument physically where you have the two bottles. The one on the left is 1 and the one on the right is 2. So that's where the channel is coming in. And then the last thing to do on this box, this window, is to tell the system how often you want to calibrate. So like I mentioned, we want to calibrate approximately once per hour. So usually I take 1 hour and I divide it by the length of my method. So this method is approximately 20 minutes. So we have 3 samples per hour, right? 3 times 20. So we'll calibrate every 3 samples, and that'll give us very good mass accuracy and so on. So you just need to make that little calculation and then choose here, calibrate every 3 samples. I guess for the beginning, you probably won't be changing the methods too much, although we'll see today how it goes. So probably you'll leave it on 3 if you keep using this method, at least for the beginning, to get started. Okay, so that's all I have.
Yes. So how long takes the calibration?
The calibration takes 2 minutes.
Oh, okay.
Let's just check that. So we can go to the queue, right? And then here's the samples that ran last night. And here's the calibration. And so what I can do, I can double click. And here's the data file. And you see, actually, I'm not telling the truth. So 1.1 minute and almost 1.5 minutes. 1 minute and 20 something like that. 1 minute. Less than that. 1 minute. Yeah, about 1 minute 20 seconds. So not too long.
Yeah.
All right. So any further questions on the batch? I mean, obviously you have buttons like new, open, save, print, right? I don't have to tell you guys about that. You guys can explore all of that yourself. Under manage samples, you have like add, delete, insert, and so on, copy, paste. So you can, that's all standard stuff, right? And then here you have actually plate layout. So if you want to just check the layout, you click on the plate layout, and then you get here, maybe we can make this a little bigger. So you get here a picture of the auto sampler plate. It doesn't make it bigger. Okay. So you have there, where are the positions in the auto sampler? Physically, you can check, okay, it's correct up to 9. Personally, I don't find this too useful because after a couple days, you guys will find the positions very well, but you can come and use that if you want. Of course, like we did yesterday, you can also just type here in this file position column. All right, so I think that's enough for the batch. Anybody have any final questions? The batch?
Alek, for the creation of the batch, you would need to save it after creating it or just submit it?
It's not necessary to save.
All right.
But I recommend it because you can actually start to use the batch as like a template. So when you click on the batch, you get an untitled one. But if you have saved it, then you can say open, and you can open your old batch, and then you can do save as, right? And you can change it for today, and then that may be helpful so you don't have to do so much administration work in your batch. So you can use it like a template for every day. Also, it's nice if you do save it, you have a record of what was done on that day. Because the queue will disappear after some time. The queue is not a permanent record. But by saving the batch, you have a permanent record. So the queue, if the software crashes, or if you restart, or if you reset the service, the queue will become empty. And also anybody at any time can come here and say clear queue. So this is not a permanent record. So that's also another reason why I like to save my batches. Then I know, I have my work I've done for years, and then I can go back and see, oh yeah, on this day I did that. But it's not necessary to save. You can click submit directly.
All right, great.
Okay, I have a question. If after submitting a batch, and then we want to add to the batch like 2 or 3 other samples, we forgot to add them. So if we add them to the batch, and we should submit them once again, and it will be added to the same queue.
Correct. So the batch is in no way everything you have to submit. So let's say you did that, you submitted 1 to 26, and then you added 27 to 30. What you can do is you can highlight just those rows, 27 to 30, like that, and then you can come and you can say submit, and you will see it will submit now only those 4. So you can submit from the batch multiple times, again and again and again. You can submit 1 sample 30 times, or you can submit 30 samples once. It's really up to you. And again, you have no fear of overwriting. It will just add to that data file. So if you do end up with multiple samples in the same data file, that's not something to be afraid of. So yeah, absolutely. Just I don't know how you want to organize it. I organize it by days. So I have a batch for each day, and then I have this letter. Sometimes I may then work on B and C and D. It's how much work I'm doing. And also you can add to the bottom here and keep going. It's also okay, either way.
Okay, one more thing. I have a question also about the quality of the calibration that's being done. If we want just to monitor it, I mean to see the results. Okay, we know it from other places that you can see the resolution, the actual resolution, and the actual mass accuracy that we've got. So if we want to see it right here from the batch, how do we do that?
Yeah, just by double-clicking on the green check mark, or, let's say the calibration failed, then you'll have a red X. You can double-click on that mark. So if you have a red X and you want to know why, you can also double-click, and you will get the report. And I think somewhere here, does it talk about resolution? Yeah, right here. So here is a resolution column. So you have here the mass accuracy. Where is it? Right here, ppm error after calibration, and you have here the resolution. So this is information that is saved in this report.
Okay, great. I have also one last question about the error before calibration. If the error, let's say, was above 2 ppm, like in this case that you opened, as you can see on the low masses on the 200 and the 300, it's more than 2 ppm. So our confidence is a bit compromised.
Well, no. So what is that relative to? ppm error before calibration is relative to what?
It's relative for the sample that has been run before.
No. Relative to the calibration. Yeah, right, exactly. Relative to the last time it was calibrated. So if you remember yesterday, well, we can look. Let's have a look. I don't know what's the answer. I was going to ask myself a question, but I don't even know the answer. So when was the last time it was calibrated? Probably here, right? So this was run on.
You can use the other calibration, the one that's beyond that to monitor. No, I mean today, not the old ones.
Right. Wow, so the system wasn't used for a month?
Yeah, that's why it doesn't. I think it was
That's why I'm pretty much amazed, because usually if you don't use the system for a month, then you have something like 40 ppm. Okay, so yes, but so I think my next point is exactly what you were saying. Let's open the second calibration. And oh, whoops, I double-clicked the wrong thing. My mistake. I will double-click correctly now, the check mark. So here we can see Now we have before calibration. So it's also not so great. So
Yes.
probably what happened is the instrument warmed up because it was not used for a month. And I don't know if the heaters, so there are little heaters in the time of flight, and the purpose of the heater is to keep the metal of the time of flight chamber the same temperature. And as you might know, if metal is cooling or heating, it will change its dimension. And if we change the dimension of the time of flight tube, then we will, of course, change the time that it takes the ions to travel. So for that reason, maybe we turn on the system and then we didn't give it enough time because it was off, or let's say not used for 1 month. But we did equilibration, right? We did about 30 minutes of equilibration while we were typing the batch. So I am a little bit surprised by that, why it's so much. That to me would be something after 1 month, I would see those numbers. Let's check the next one.
Exactly.
Here. Yeah, that's more reasonable. You see it's adjusting. That's more reasonable. Some of these are a little bit out of spec after just 1 hour. Let's see the next one. Yeah, it's more reasonable. Before calibration and after calibration is really excellent. Well, we'll see how we do when we look at the ppm of the compounds. But to be honest, I don't look too much at the before calibration because this is relative to the last time it was calibrated. That is a little bit interesting at the higher mass. Look at it in millidaltons. Expected 6033, 6076. Yeah, so that's only 4 millidaltons out. I think it's okay. We'll just keep our eye on it. And actually, the nice thing is you guys have a high mass compound, right? The antibiotic you want to look for, whatever today, is high mass. So we'll definitely see if we have a problem or not. But I would say that was fairly normal. I don't know if you remember yesterday, but when I was submitting the batch, then Samar chimed in and said, "Oh, why don't you do the quick tune?" And to be honest, perhaps we should have done that, but we were just a little bit pressed for time. So one thing that you can do, I'm not sure that it really needs to be done every day if you're using the instrument every day, is to run something called the quick tune just before you run your samples. We were recommending to customers to do that every day, but we found that people were using the calibration mix then quite a lot. So I kind of changed my opinion, and I say now you should do it every 3 or 4 days. However, I guess I was not really aware also that the instrument had not been used in such a long time. So I think definitely we should have done the quick check yesterday. And if we had done that, then our beginning numbers would have been a little bit better. So that's something to keep in mind. The next time we run a batch, I'll definitely show you how to do the quick check. And then you can do that based on your judgment of how long it's been since the system has been used.
So
Okay.
Alan will make this number better. Okay, sorry, Rania, go ahead.
Sorry, Rachel. Alek, regarding the equilibration.
Yeah.
So before submitting our batch, we have to equilibrate. So can you please tell us, when you do equilibration, what is actually happening to the instrument?
Okay, sure. So right now, the instrument it's powered. The electricity is powered on. The vacuum is there, but the instrument is not, let's say, quote unquote, doing something. So it means that the ion source is, let's say, cold, and that the HPLC pumps are not pumping, and the column oven is not at temperature.
All right.
So those are all things that take a little bit of time to warm up. So especially anything to do with pumps and pressure and anything to do with heat will take a little bit of time to get ready and stabilize. So when you click equilibrate, you have the option to choose you don't have the option, you are forced to choose your methods. You have to choose an MS method and an LC method. And what will happen is the beginning conditions of those methods will load to the instrument, and it will start doing that. So if your source temperature is 400 degrees, it will start the source at 400 degrees. If your HPLC flow is 0.5 mil per minute, it will start that. If your column oven is 40 degrees, it will start doing that.
Okay, great. Thank you.
I think there was a second question
Yes.
that was overlapping.
Yes. So my question was, if we do the quick MS tuning before going to the batch, does these numbers from the calibration will be better?
I don't think it will. So just to clarify, the number that I'm really concerned about is after. It's this number here. I don't think it will improve this number. As you saw in every case, this number is okay.
Okay.
What the gentleman was asking is, should we be concerned about this number before the calibration? My opinion is that this is relative to the last time you calibrated it. So who really cares, because maybe that's a long time ago. However, there is a point that if you are calibrating it every hour, that this should be correct, and I do agree with that. So looking at this column, you really have to think carefully about the history of the instrument at this point. Doing the quick check will affect this column, yes. But doing the quick check will not affect the result here, because the quick check is in the past, and this is a new calibration here, automatic calibration. So what you really want to be concerned with is always how the mass error is after the calibration.
Okay, I see. Thanks.
Alek? Question.
Yes.
When the batch, when the sequence is over and then the experiment is finished, the LC pumps will stop automatically, or?
Correct. Let me show you that. So, because we had a few questions now on this point. So, under configuration, you have some control of your queue. So actually, it's not 30 minutes, it's 20 minutes. We can adjust it here. So this is instrument idle time. So what does that mean? That means the amount of time that the instrument will continue to do the last thing that it was assigned to do before it goes to idle. So at the end of the last run, the run finished, the data was saved, and all of those things that I just talked about when the lady asked about the equilibration question, they will continue. For 20 minutes, whatever time you have in this box. And then after 20 minutes, those things will stop. So the instrument never turns off, right? The electricity is there all the time. The vacuum is there all the time. But the things that are using heat or pressure will stop. So it means you will need to budget your HPLC solvent 20 minutes extra from the end of your last run.
Yes. Thank you.
Now, okay, while we're on the same page, we have some interesting settings here. So you can say if a sample is missing, proceed to the next sample. So that means that if the auto sampler doesn't find that vial, So if you told it to go to position 36 and it goes to 36 and there is no vial, what do you want it to do? Right now it's checked, so it means that it will continue with the next sample. It will skip that one and continue. So it's up to you if you want that checked or not. You can decide yourself. One problem of having it checked is if you missed one vial and then you put all your samples in sequence after that, each one of your samples will be, let's say, off by one, right? So just keep that in mind. And if a sample does fail, you will have a red X. So I don't know if we can see a red X. Oh, sorry, this is the batch. Let's go to the queue. Do we have a red X to show you? So no red X's. So this will be a little red X, and then you will know that it's a warning. So it is important to come to the batch and to always see, is everything a green check? Then you have here a checkbox. If the calibration fails, proceed to the next sample. So right now it's unchecked. So if the calibration fails at any point, that means it doesn't pass the spec. Then it will stop and it will go into the standby and it will wait for you to come and to start it again. So you can check that if you want or not. The calibration data is saved. So we are saving the calibration data there, and that's why you can double click on the line and see the data file. So those are the settings there. You have auto calibration with CDS, and it says purge the CDS at the next batch submission. Yeah, I wouldn't check that. If you check that, you're going to use a lot of that solution very quickly because it's going to purge the system every batch, and you'll waste like maybe 5 or 6 mils every time you run a batch. So I suggest to not to check that one. But the first two, you can decide amongst yourselves which option is the best one. And you can control that amount of time in this box here. And don't forget, it's not just changing it, you then have to press save here. The save is so far away, so just remember, come and click save here. Okay, so that I think is a good overview because we went quite fast yesterday in the batch and the queue. Any questions? All right, so we went so fast yesterday that we did. Oh, yeah, yes, please. Yeah, yep.
Tony, sorry, I watched in the middle of the session. I just have a quick question. If you're shifting between positive mode and negative mode, I don't know, you probably got that question and answered it, but I wasn't there. If you're shifting between positive mode and negative mode, do you advise running several blanks or just one blank would be enough?
Yeah, we didn't, actually that question didn't come up. Yesterday we were in a little bit of a rush. So right now we only have positive methods, so we didn't talk about negative. But yeah, absolutely, I would agree with you that you should have several blanks. The instrument probably needs, let's say, at least 5 minutes to kind of settle down between positive and negative mode. So maybe I would do, 1 or 2 blanks definitely to allow the instrument to settle down. And also the calibrations may fail at the beginning.
Yes.
The reason for that is not from the instrument, but the reason for that is because the calibrant solution is different and it may not fully have purged out of the ion source. So if you are going to do positive and negative in the same batch without any human intervention, I would do, probably 3 or 4 blanks is a good idea.
Okay, and one quick last question. Supposedly I want to do some specific proteomics analysis, and I want to switch the solvents into acetonitrile with formic acid and water with formic acid, but adding to them 1% DMSO. Would you also run blanks prior to your sample several times, or you just leave the LC at a specific flow rate? So I used to be in Maxis 4G user broker. And we used to have to run several blanks before running our samples, not just keep the LC at, say, 0.3 ml per minute for half an hour or 1 hour before you start running your samples. Would we have to do the same in this case or not?
Yeah, that was quite a loaded question. If you don't mind, I will just make a few comments. I would be very careful about running DMSO on this instrument. We did have a big discussion actually about that yesterday because some of the colleagues there, they prepared their samples in DMSO, and I was a little bit nervous about that. So putting 1% DMSO in the mobile phase, I'm not sure that the interface will be able to handle that very well. I would be careful with that. If you can do without it, I would try that.
Okay.
Now, okay, having said that, we did also have a discussion about the LC has different solvent channels. So you can install in parallel up to 4 solvents, 2 for the A and 2 for the B. And you can choose those in your LC method. So you are able to run a batch with different gradients in it. That it depends how long the tubing is. I'm not in the lab, so it's hard for me to judge. I usually chop that tubing down so that there's no extra loops hanging around because the extra loops add dead volume. And then when you do switch, you have to wait for that. So I would shorten those tubings, and then I think it's probably a good practice again if you do switch the LC to go to run 2 or 3 blanks just to clear that dead volume from the switching valve to the pump heads.
All right.
Yeah,
thank you.
You're welcome. But I also want to go back to your positive-negative switching question. So let's say that you had here 1 to 15 was positive mode and 16 to 30 was negative mode. So the way that you would do that is that you would have, you would just choose your different methods. One would be positive and one would be negative. But the system does not allow you to submit that batch as one submission. And the reason for that is under the auto calibration, you just choose one, right? So you've got to choose one mode and say, okay, and then highlight all of that mode and submit it. And then you've got to go back to auto calibrate and change it to your other mode. And don't forget to change the channel as well. And then highlight the second mode and submit.
Okay.
Anyway, it will give you an error message and it will tell you that. So it will be, I think, easy to understand. But just as a warning, don't submit positive and negative samples in the same submission. But they can be in the same batch and they can definitely be in the same queue.
All right.
Yeah.
Thank you.
Yes, you're welcome. All right. So any further questions on batch or queue? And don't forget, batch and queue is definitely a video in SCIEX OS. So if you do need a refresher, if you do go on Christmas break or whatever, and you come back and you do need a refresher, then those videos are there. All right. So yesterday we went quite quickly. So we didn't really discuss what are the nature of these samples. So maybe if it's okay with you, I could ask whoever is the owner of these samples to just maybe give us a little bit of an introduction. What are the samples? What are we expecting to see in them, or what do you hope to see in them? And then based on that information, we can decide which sample set to start with. So don't forget, we made 3 methods yesterday. We made just the TOF-MS method, and then we made an IDA method, and then we made a swath method. So we have 3 data sets from the identical samples. And then we'll decide which mode to progress in. So you have 2 modes, and don't worry, when we're done with the training, or maybe even into January, we will discuss everything in both modes. But you do have 2 modes of data analysis. Explorer is a little bit more manual, and analytics is a bit more automated. Explorer is where you could go and find certain things and really dig into the data and click around and see what's there. And analytics is more guided for quantitation and also for finding unknowns and so on. So analytics is method-based. We have to make a processing method. And Explorer, we don't have any kind of method. We just are presented with the data file and we just go into it and see. So that's the difference there. Who is the owner of these
Alek,
samples?
may I suggest that we start initially with the data processing of the triazine mix that we already have done at the custom formalization stage, because we haven't done that yet.
All right. Okay.
And then we can move to the samples that we ran yesterday, if that's possible.
Sure. Yeah, absolutely, we can do that. So let's see, what do we have? So that would be in the queue, right? So here, so these are the triazine here?
Yes, that's it, yes.
Okay, and you just ran 10 nanograms per mil?
Correct.
Yes. Okay, so, all right, we can start with that, no problem. That's in a different project, that's in the triazine project. All right, so you have a choice. Well, let's start in the automated, that's easier. So that'll be under analytics. So the first thing I'll do is I'll change the project to the project which has the data in it that we want to work in. And it's just saying that when the project is switched, then if you didn't save anything in your batch or your methods, they'll be lost. So we don't really care about that. Everything we have is saved. So we'll just say yes. What happened? Did I lose control? Are you guys still there?
Yes, we're here, but I guess the PC is processing.
Yeah. There we go. Okay, we're back. All right, so this is the analytics mode. In order to proceed in the analytics mode, you must have some data already. So you cannot start in analytics without some kind of data. Ideally would be a standard injection, or if you're working in unknown analysis, already your sample analyzed. So you can see right here, it says begin by creating a results table or opening an existing one. So that's under results. Have here new or open. So we're going to say new. All right. Every time you start in analytics, you have this same window, and it always asks you to move the data that you want to process over to the right-hand side. So we'll find the triazine samples. So here they are. And we'll just take a few of these 10 nanogram per mils. Let's do 3 of them. And we'll move them over to the right-hand side. So we have the option later on to remove samples and to add more samples. But to start with, we have to move something to the right-hand side. And this is going to be the samples that we use to build our model for the method and to process. The samples that are moved to the right side must be collected in the same way. They must have the same data in them. So it wouldn't make sense, for example, to move positive and negative data that are separate over to the right-hand side, for example, because those data files would be totally different. So there has to be at least a common thread through all of the data that you move to the right side. And then here you have the processing method. Browse will be to select your method once you have it. Today we don't have any methods, so we'll go to new. So keep in mind, building the processing method is not something that you will do every day. The idea here is that we have a processing method to detect a certain amount of compounds, and then we are using that processing method repeatedly in the future to process more data. So
Alek,
normally,
I believe we
yeah.
already have a processing method which we designed with the Mirai, but I'm not sure. Maybe
Okay,
yours might be
well-
more tuned, I guess.
Yeah, let's go through it ourselves. Okay, so he makes some methods for you here. All right. You even have a non-targeted method. Great. All right. Well, maybe shall we just start from new? I think because
I guess it's
then-
better if we can start fresh, yeah, with you.
Yeah. Okay. Yeah.
Please,
And also-
yes.
Okay, because maybe everyone was not there for his section.
Yes, that's
Mahari's
correct.
section, I mean.
Yeah.
All right. So okay.
Sorry,
so
but I have a question. Have you run
No.
tracing with 3 different MS methods?
To be honest, I don't know.
No,
it looks like
no,
they just
one.
did IDA.
Just idea,
Okay.
yes, correct.
Okay. Yes.
There is. So what is TOF MS? So they did
TOF
TOF
MS
MS
and
alone,
IDA.
it looks like. They did IDA. I don't know what is this actually. So actually, that's a good point. I didn't catch that. Let's look at the IDA because it's a little bit more interesting. Okay, we'll do the IDA. However, I want to change some default setting, which I forgot about, to make your life a little bit easier, and we have to do that by canceling. So in the analytics section, there is something called integration. Right? And integration means we are taking the area underneath a peak to try to establish how much of that compound was present. And there are different algorithms for the integration. And you can set that under here, projects. You have project default settings. So what I'm going to do is I'm going to change your default settings now to the preferred algorithm. So the preferred algorithm is what's called MQ4. MQ4 stands for Multiquant, which is the software that came before SCIEX OS. And MQ4 gives you a little bit more information here, or let's say settings here that you're able to adjust and to play with. So I think it is preferred to use MQ4. So I'm just going to save that, and also I will do it for the project that I set up. Then I will do it for your default project, and after that it should be done forever. So all the projects that you make are born out of the default project. Just save that. Okay. Great. All right. So back to triazine, back to results, back to new, and then we will select the IDA samples. Let's choose 3 of those. Okay, and we'll move them over to the right side, and then we'll say new. Okay, so now we're back where we started from. Okay, so here you have the steps of building a processing method, and this is basically the workflow that you're going to follow down the left-hand side. The first step here, it presents to you all of the samples that you added, and it asks you to choose a reference sample. The reference sample will be what is integrated in the method steps here, and it will be what is used to build the model that sits with your method. It is not actually the integration of that sample. That will happen in the next step when we actually do the processing. However, as it is the model or the reference sample, we do want to make sure that we choose a sample that has all of the compounds in it that we want to identify, or if you're doing unknown work, that it is as close to your real sample as you can imagine. So here doesn't matter because the samples are the same. However, for example, if you have a calibration curve or something like that, I usually choose a sample which is sort of in the middle of my calibration curve. So I'll just choose the middle one. And for today, it doesn't matter. But when you have different samples, make sure that you've chosen something that's like a standard. Now up here we have the workflow that you want to proceed through. And you have three choices. The base is always a quantitation. Quantitation at least gives you the integration of the peaks. So even if you don't want to do quantitation and you just want to do identification, as you can see, you cannot choose just quantitation and target identification. It also has quantitation always. So that just means you're going to get peak integration. Whether you want to actually do quantitation or not, that is up to you on how you interpret the data. But we're going to start down that path. Non-target screening is the last choice. You can do that in addition to quantitation, or you can also do that by itself. And so non-targeted screening would be using an automated algorithm to go through the data and to find really unknown peaks. So I think that one is a little bit more complex, so we'll leave that for a second, and we'll start with quantitation and targeted identification. So the goal here, what we're going to do is we're going to try to build a method that will find these triazine pesticides in samples, and we'll do some library searching also on the MSMS data in order to identify the triazines in your real samples. So I know you can pretend, for example, that you're doing water analysis and you're looking for these pesticides in some water samples or something like that. Let's say that to make it a little bit. Okay, so once I've established those two things, I'll continue down the list. Components. So under the components, I have to tell the system, well, what are the compounds that I'm looking for? So what do you need here? On a very minimum, you need the chemical formula. If you have also the name, that's great. But basically from the chemical formula, the software will be able to calculate the mass and the isotope pattern. As you remember, on the first day, we spent a lot of time talking about isotopes and the pattern and the exact mass and so on. So what do we need? We need the triazine mix. Do you have it on this computer, or did Mari leave it for you somewhere? Installation files and documents, HPLC, maybe it's in this Excel. Doesn't look like it. So what I will do is I have it in an Excel sheet. Okay, so just give me a second because I have already in a nice sheet. Where am I looking for? Just give me a second. Right. So what I'll do is I'll send it to you. Send the file. And I'll put that also in the V drive in my folder, triazine save. All right. Well, now it should be here. Yes. Now it's going to be the wrong file. No, it's correct. Okay, so these are the pesticides which are in this mix. Here are the pesticide names, and here are the formulas. So what we can do is, the nice thing about building the method is if you do keep all of your compounds in Excel, you can just copy paste. So we have the formulas. So I'm going to paste the formulas right into that column. And it gives an error message because it does want a name. So I will go back and I'll just grab the names. And paste the names there. Okay, so that's what you need as a bare minimum. You see here you have the addict the charge. So if you know, for example, that you're dealing with an ammonium addict or something, you can always find that in the list here and change it. These guys all make protonated ions, so that's okay. Now we have the precursor mass filled out automatically. So that is the monoisotopic exact mass of the charged species. And it got that from the chemical formula. Here you have the XIC width. That is the amount of width that it will use to produce the selected ion chromatogram that we will see for the compound. We're going to play a little bit more with that when we go in manual mode. So I'll just, if you don't understand completely how that's working, I'll show you that when we go to manual mode. Right now we don't know the retention time because we didn't look at the data. We don't have an internal standard in this experiment. We're not doing quantitation. And here you have the experiment index that it's looking for this XIC in. And pretty much you will always have here the TOF-MS. So we will use the TOF-MS as the survey scan to find XIC, and only the MSMS data will come from the IDA. So I think even you cannot change it, yes, because it knows that it cannot look for parents in the IDA data. It can only look for the parents in the TOF-MS data. So that's our first method. We're going to make now targeted method for these compounds. So any questions on this chart?
So every time we put the formula, we will have the mass,
Exactly.
monoisotope. Oh, okay.
Yeah.
Automatically.
Automatically, yeah.
Okay.
So let me see. Sometimes the software is a little weird. It won't give me an extra row below now. But I was just going to demonstrate. So, yeah, if you type, so for example, C5, H2, someone was talking about iron and stuff yesterday, right? What is going on? Why I can't type? Oh, did we lose the control again? Uh-oh. I lost control. Can you guys still hear me? Okay, we're back.
Yeah.
Maybe. Okay. So I can type, for example, C5, H3, and then someone was talking about iron and so on yesterday. So yeah, no matter what you type, as long as you type it exactly like the periodic table, it will put for you the charge, whatever this is, charged monoisotopic mass. So don't write chlorine with a big C and a big L, right? That's carbon and lithium, or not, what's L? Li is lithium, right? Or L is lithium? I can't remember. Li, yeah, what's L? L is something else, isn't it? Shows you how well I know my periodic table. Anyway, you can't write it like that. You have to write it big C and little l if you want chlorine. And conversely, for lithium, you write big L and little I. Don't write big L and big I, because that's lithium and iodine. That one I know. Makes sense? So you have to follow exactly how it is on the periodic table. All right, so I'm going to delete that row. Now I have my extra row below. Okay, strange. All right, so yes, good question. Any other questions from this chart? If you're using a stable isotope, you can put it as you would the correct notation. So, for example, if you have a C13 labeled, you can put a brackets, and then you can put 13C5, would be 5 carbon 13 atoms, and you see it knows that. Okay, it's confused because I didn't put a name. All right, so if you are using deuterium, you put 2H3, means 3 deuteriums. So the number, if you remember, the superscript number in front of the chemical symbol or the elemental symbol means the change in the neutrons, right? So that's how you will put isotopes, if you want to force it to remember or force it to use the isotope. Make sense? Probably carbon and hydrogen are the important ones. Oh, nitrogen, right? Some people use nitrogen 15. So then if you have 2 nitrogen 15s, you do it like that, 15 and 2. So the number before is the number of neutrons, and the number after is the number of atoms. And you have to have it in brackets. Or actually, those aren't brackets, right? Parentheses.
So Alek, it is not necessary to add the retention time. We can do that without, right?
Good question. So what we're going to do is we're going to actually find that in the next step when we go to integration. So when we go to integration, it's not actual integration, even though it will look like it. What it's doing is it's integrating that model sample, and we'll be able to find the retention time. And once we've done that, that column will populate. Now, if you do know the retention time ahead of time, of course, you can also come here and type it if you want. But because we didn't look at the data yet and we don't know, it's blank until we get to the next step. All right. Any other questions from this chart? Alrighty, so we'll go to integration, and now you see, leading directly to that gentleman's question, you have here the list of compounds which you typed in the components, and when you go through each one, you see on the very right side the chromatogram, and you see in the chromatogram the peak that it has integrated, and it has the retention time. So actually, if you go back now to components, you'll see that column has been filled out. And that column is filled out from the information that it got from the integration. So basically, I think for today, we're not going to go too deep into the integration parameters. We'll come back to those perhaps in an advanced session. I'll just talk about 3 parameters which I think are important. So you see in each case, it has integrated the tallest peak, the most intense peak. So the first thing to do is to check that you are happy with that. In most cases, I think you will be. Let's find one where, yeah. So let's say, for example, you know for some reason that this is the peak and not that one. What you can do is you can drag across the one you want, and it jumps to that one. And then you see your retention time, your expected retention time is updated with what you have selected. So here you are able to choose exactly which peak you want. Now you have a couple interesting settings about retention time. You have a search window. This RT half window, that means how wide is the window that the software will search for the compound in. So 30 seconds is half the window, right? Keep in mind it says RT half window. 30 seconds is half the window, and it will be centered on 0.8. So in your data, when we do the processing, it will search for a peak 0.8 plus 30 seconds and 0.8 minus 30 seconds. And it will integrate a peak in that window only. So if you see another peak at 3 minutes or something in your data, it will not jump that far because it's outside of the window. And then you have this setting, report the largest peak. So if this is unchecked, it will find the closest peak. So right now it's unchecked, it will find the closest peak to 0.8. If you check it, it will find the largest peak within this window. So even if there's another peak that is 20 seconds away, If it's bigger, the biggest peak, it will jump to that peak. So because in this case, I think our chromatograms will be quite clean, we can leave that unchecked, and then it will jump to the closest. But you do have control of that, and also you can update this so it's not as wide. You know, even 15 seconds is a large jump in time for a peak in LCMS. So you might want to make that smaller. Okay, now the integration parameters. So just quickly, I want to talk about 3 of them I said. So the first one is a smoothing. So let's just zoom in here a little bit and we can see the peak. So right now it's smoothing of 0. And keep in mind that we are right around 3E5 height, right? So if I do a smoothing of 1 and I say apply, all right, so now let's zoom back in. Okay, so maybe the peak looks a little bit better to you, not much, but look what happened to our height, right, and our area. It went down by a lot. So smoothing improves the peak shape, but at the expense of peak height and peak area. So be careful. Don't use smoothing to try to get the most perfect peak, because you will lose also a little bit of sensitivity. So the rule is that I use the minimum smoothing that I need. Don't overdo it on smoothing. And you can also use fractions. So you can say half. So does anybody know? Let me ask a question to you all. So let's say you have a horrible peak shape, like actually this peak doesn't look very good, right? This peak looks very like a triangle. And you see that? So see these, especially down here, right? We can see there's one data point, there's another, there's a data point, there's a data point, right? So I kind of gave it away. So what would you do to your data or to your method, let's say, if you have to apply a lot of smoothing, which we just talked about is bad, you'll lose intensity. What's one thing that you can do? Anybody have any ideas? We did talk about it yesterday when we did method development, a little bit. We just touched on it.
Maybe to increase the number of points.
Exactly. That is exactly the correct answer. So what you need to do, if you find yourself using a lot of smoothing to get a good peak shape, is you have to go back to your data, or excuse me, back to your method and adjust your cycle time so that you have enough data points. So this peak will be much better defined if you had more data points, and then you would not need to use as much smoothing. So that is exactly the answer. Smoothing is not the answer. The answer is go back to your method and adjust your timing so that your data points are correct. In other words, if you have the correct number of data points, you don't need to use a lot of smoothing. The 2 other settings which I find useful in all of these settings here is the baseline subtraction window and the peak splitting. The baseline subtraction window helps you to define the base of your peak. So usually what I put here in this box is approximately the width of the peak at the base. So what do we have here? This is about 0.2, I think, right? Is that about 0.2? Oh, no, sorry, it's way less than that. It's that's 0.1. Oh, so these are really narrow peaks. That's our problem. Okay, so this is like 0.05, right? So I'm going to round that up a little bit to 0.1. So in the baseline subtraction window, I put approximately the width of the peak at the base in minutes. And that's going to help you to prevent peak tailing and so on. So if you adjust that correctly, then the start and stop of the integration will also be good. This is having trouble because there's not enough data points, so it goes out. Let's try 0.05, see what it does. Yeah, so you see that? Now it's closer in, right? It doesn't have the tail. So you are defining approximately the width of the peak at the base that you want. Unfortunately, there's no real right or wrong, so you can do whatever you want, but this is just kind of my little rules that I share with you. Now, peak splitting really only is helpful if you have two peaks that are close together, very close together, and you want them to be integrated either separately or together. So you adjust this number to do that. I can show you in the paint. Oh, I still have my drawing from yesterday. All right, so for example, here we have our chromatogram. Here's time, here's intensity. So we are talking about peaks that are like this, right? So do you want that to be integrated like this? Or do you want it to be integrated like this? Right? So that's your choice with peak splitting. It doesn't work with peaks that are this far apart, right? This already has baseline separation. So we are really talking here about peaks that are not well separated. And decide using this number higher or lower if you want the peaks to be separately integrated or integrated together. All right, so for right now, I think that gets you started. The other settings are all kind of minor, so we'll definitely talk about those, but not today. So basically, I just go through and I'm going to update my baseline subtraction window for each one, because that one I know is 2 minutes is too much. And I'm just going to check and look and see my peaks are okay. I will leave that one at 0.5. And okay, so that's good for the integration. And like I said, now we have identified the retention time, so that shows up now in the method. So at this point, after you've done those 3 steps, you can say save. You are basically have done with making the most simple method that we can make. In this case, we'll continue through the library search because we do have IDA data, and we can use that to search the library. So we'll turn on the library search. And we'll talk a little bit about flagging rules, which I think are useful in helping you to identify if a compound is present or not. So let's keep going. So library search, you have a checkbox if you want to use it or not. And then you can choose which libraries you want to search. So you have a lot of libraries. Okay, great. You have an algorithm here, library search algorithm. So what this is doing is it's searching the library in 2 very different ways. Confirmation search is using the name first. That sounds a little bit silly, but if you think about what it's doing, it's confirming. So it's only matching things in the library that have the same name as what you typed in the component list. So atrazine will only match against an atrazine hit in the library. That prevents you from cross-matching compounds. That is useful in a true targeted analysis. It may not be useful for you guys when you are trying to find new things and do research and so on. You have smart confirmation. Smart confirmation will do name matching first. If it doesn't find a name match, then it will search the whole library anyway, and it will give a little asterisk that it found a match, but not by name. And candidate search finds the best candidate no matter what. So candidate search doesn't care about the name. It's just traditional library search based upon how well the data matches the library. So let's do confirmation, smart confirmation. And We'll see. You have the option to change it later if you want to candidate. Now the results here, you can sort them by purity, fit, or reverse fit. And we did talk about this a little bit when we talked about swath in the lecture. So IDA data, which this is IDA data. IDA data is what we call clean MSMS. So all of the daughter ions in the MSMS spectra will be from the parent, the single parent which is selected, right? So in this case, we can use purity. So purity is the best way to search IDA data. Excuse me a second. All right, sorry about that. All right, so purity is the best way to search IDA data. And if you remember when we talked about swath, we said that there may be extra peaks in our data, right? So those daughter ions may come from another parent, which is in the same window, but not exactly the parent that we are trying to library match. And that's okay in the fit algorithm. So the fit algorithm looks that every peak in the library matches as a match in the data. But if there are extra peaks in the data, it doesn't affect the fit score. So that's the difference that you want to use here for your library search. Purity for IDA and fit for swath. And your scores will all be, let's say, correct, and they will match the data that you are using. So this is IDA, we'll leave it on purity. Now these libraries that you have are actually our latest library. The HR stands for high resolution. So these are pretty good libraries. So you can leave these settings here. If you start using other libraries and third-party libraries and so on, I will show you what are the, let's say, what are the most open settings or the most flexible. And that would be basically to turn off the collision energy search. So when you have the collision energy search on, it's searching not only by the mass, but by the collision energy that your data and the library data was collected under the same conditions. That doesn't really make a lot of sense when you have, like I said, a third-party library. These settings are the most open, like this, and then I would turn on the collision energy only if I know that the library is exactly matching my conditions. And then you have also a tolerance for each one, so how many volts you want to be within tolerance and how much collision energy spread. So just to keep it open, we'll turn those off for today. You have also the mass tolerance. So 0.4 Daltons is quite a big tolerance, right? And so when we are using high-resolution libraries, and all of your libraries are high-resolution libraries, we can mark this down a little bit more. So we could put even 0.05 would be a good, still quite a wide tolerance for high resolution. And fragment mass, the same thing, 0.05. So that's going to be plus or minus 0.05, gives you a 0.1 Dalton window that the masses have to be within. So for high resolution, I would leave it something like that. The other settings, I think, for us are not so important. You can search by retention time here, but then keep in mind that the retention time of the compound in the library has to be correct. And the library may be collected under different chromatographic conditions. Whereas here, already under components, we have already retention time here. So we're using this retention time anyway to find the components based on the standards. I would not turn it on extra in the library. Okay, so that's the library search. Anybody have any questions on that? It's the key that you understand fit and purity. Everybody understand the difference between purity and fit? Are you all there?
Yes.
Yes, okay. All right, good. Okay, so this is an IDA, so we leave it on purity. Okay, let's keep going down the list. So we have calculated columns. Under calculated columns, we're going to leave this for now. This is actually something very powerful, especially if you do quantitation. What you can do here is you can write a little program that will help you to interpret your data. So you can say, for example, you know, if a certain peak has more area than this peak, give it a mark, give it a flag. You can also do things like summing and averaging and means. So it's kind of like a little Excel program written into your method. For us, it's a little bit too complex, I think, for just the beginning. So we'll skip it for now, but we can come back to this. Like I said, especially if you do quantitation, this is a very powerful tool. Flagging rules. So under flagging rules, we have little flags, is what they're called, and these flags are different colored marks that appear in your results, and they help to draw your attention to something that is either good or bad about your data. So for you all, especially in this method, we are sort of doing a targeted screening. So I would turn on the qualitative rule. You see the other rules here, the accuracy, concentration, and integration. These are more based for quantitation. So I'm going to turn those off for now. And we'll turn on the qualitative rules. And then if you click the heading, it goes into the details about the qualitative rules. And here you see that you have 6 different criteria that can help you to confirm if the compound is present or not. And each criteria has 3 ranges. You have a green range, and you have a yellow range, and you have a red range. So for example, if we turn on the mass error, we may say, okay, green is less than 3, and yellow is between 3 and 7, and anything bigger than 7 ppm mass error will be a red. And of course, you have the power and the flexibility. You can come here and type what you want for your own flags, depending on how narrow or how wide you want your interpretation to be. Again, these are only flags to help you to interpret your data. So the idea is to make it easy for you to see what you want. So if you want to see things that are better than 5 ppm, you can also come here and change that. So today we'll just use my, let's say, preferred numbers, but keep in mind you can come here and change these numbers. There's not really any rules related to that. Okay, so fragments, we don't have fragments today. We don't have any known fragments, so we won't turn that one on. Retention time we have, so we can choose between percentage error and absolute error. So maybe we can leave it on absolute error, and we can say, okay, any drift of more than 2 will be a green, and anything more than 4 will be a yellow, or sorry, between 0.2 and 0.4 will be yellow, and anything more than 0.4 will be a red. Don't forget, 0.4 of a minute is already quite a big drift. Here's the isotope ratio percentage. So that means, does the pattern of the isotope ratio match? So I like to make it a little bit wider. I do 15. Here I do 30. And then we have library hit score. So anything better than 70 will be green. Between 70 and yellow, yes, yellow. Formula
Okay.
finder, we don't have formula finder today because we pulled the
Alright
software.
أنا أرجمها حاضر إن شاء الله.
So when we do the non-target,
أوكي شكرا على الإصلاح.
formula finder, and I'll explain in about formula finding. If you remember, that was where we matched the formulas to the data itself instead of telling the software. So now you have to add up your parameters that you turned on to 100 in order to give a combined score. So for us, I think we just make them all equal. 25. And formula finder, sorry, we have to say accept changes and return, right? And then formula finder we don't have, or we're not going to use it right now, so we'll keep it off. Okay, so that's the first method we've made. So I'm going to save it, save as, and this is, I'm gonna call this triazines, pesticides, and this is with the library search and IDA, right? Because we set the purity, we set it to be purity, which means IDA. So that's our first method. I will say save. Okay. Any questions at this point? Saving also closes it. So if we want to open it again, we can say edit. All right. So we're going to do this many times. Don't worry. We're going to go through it many times in our training today also. But if anyone has any questions on this?
I didn't get where you went for the flagging rules. You checked only the qualitative rules, right?
Correct. So the other
Why?
So the other rules are more geared around quantitation. So, for example, accuracy would mean the accuracy of your standard points on your calibration curve. And concentration acceptance would be if a certain concentration is above or below a limit.
Okay.
And integration acceptance would be following all of those. I don't know if you've done HPLC work before, but following different, what's the right word? Following different GLP, like is the peak symmetrical, all this kind of thing. So what we, as far as I understand, you are not so interested in quantitation. Maybe I'm wrong there, I don't know. But we can easily do some quantitation at some point. We just need, so in LCMS, quantitation works with an external calibrant. So you would need to use your standard to prepare your standard curve. And once you have done that, we can process that data as quantitation.
Okay, so for the quantitation, you have to process these accuracy, concentration, and integration acceptance, right?
You don't have to, but they are only applicable to quantitative data.
Okay.
So we'll skip it for now.
Thank you.
All right. Any other questions? Okie doke. So I will say save, and then I will say process. And what we're going to do when we say process is we're going to process these samples using this method, and we will get a chart behind here. You see this white space. This white space will fill up with a chart, which will be all of our results. So I think here is a good place to take, I will press process, it will go. Here is a good place just to take maybe 5 or 7 minutes break. And I need to refill my water glass. And then we can continue looking into this results table. So is that okay with everyone? So right now it's 3:10. So we'll pick up again at 3:17, okay?
Okay.
All right. So see you in a few minutes.